Scientists have discovered the true ferocity of a huge volcanic eruption.
Volcanoes are enigmatic and formidable forces of nature with unbelievable power that can shatter the very foundation of the Earth. These colossal mountains of molten rock and ash have the ability to unleash devastation on a scale that is beyond human comprehension. While most of us don't have to see the deadly effects of volcanic eruptions every day, this volcano even exceeded our maximum expectations about how far the effects of this eruption was. It doesn't mean that they don't happen. A lot of the time though, these eruptions are fairly small, but sometimes they show their full force to make sure we know just how powerful they are. Well, NASA just announced a 50 miles eruption has cracked open the Earth and it's about to take everything down with it. Join us as we dig deeper into what happened and what it might mean for the survival of planet Earth. But before we get to that, you need to fully understand volcanoes. Volcanoes form as a result of the movement of tectonic plates, which make up the Earth's crust. When these plates collide or separate, they can create cracks or fissures in the crust through which magma, gas, and ash can escape. This molten rock is called magma when it's beneath the Earth's surface and lava when it erupts onto the surface. But not all volcanoes are the same, and that's where things get even more interesting. There are three main types of volcanoes: shield volcanoes, cinder cone volcanoes, and stratovolcanoes. Let's start with shield volcanoes, the gentle giants of the volcanic world. These are low and broad, stretching for miles and miles, formed by the eruption of fluid lava. Shield volcanoes get their name from their shape, which resembles a warrior's shield lying on the ground. Unlike other types of volcanoes, shield volcanoes tend to have long, gentle slopes, making them some of the most peaceful and beautiful landscapes on Earth. The Hawaiian Islands are home to some of the most famous shield volcanoes, including Mauna Loa and Kilauea. These volcanoes have been erupting for thousands of years, creating new land over time. Kilauea has been continuously erupting since 1983, making it one of the most active volcanoes on Earth. Despite their gentle nature, shield volcanoes can still cause destruction. When Kilauea erupted in 2018, the lava shot up over 160 meters high. It destroyed over 700 homes and forced thousands to evacuate. The families affected by the destruction are still trying to regain a sense of life today, and that's just the starting point. Now let's talk about cinder cone volcanoes, the small but mighty members of the volcanic family. These steep, cone-shaped mountains are formed by explosive eruptions of gas and ash. They're a little more cone-like than shield volcanoes, but still not super tall. Cinder cone volcanoes get their name from the small pieces of lava that are shot into the air during an eruption. These pieces of lava cool quickly and fall back to the ground, creating a pile of loose, cinder-like rocks around the base of the volcano. While they may not be as impressive in size as shields or stratovolcanoes, cinder cone volcanoes still pack a mighty punch. They are capable of erupting explosively, sending ash and debris high into the air. Paracutan in Mexico is one of the most famous cinder cone volcanoes in the world. Because it grew from a cornfield in just 9 years, covering the town of San Juan Parangari Cutiro completely in lava. This just goes to show that even if a volcano is on the smaller side and not really that active at any point, things could change. They could just start erupting at any moment and just not stop until they devour everything. But wait, we still have to talk about the final type, stratovolcanoes, the craziest ones of them all. These tall and steep volcanoes have alternating layers of lava, ash, and other volcanic materials. Stratovolcanoes get their name from their shape, which resembles a layer cake. Each layer represents a different period of eruption, giving scientists clues about the volcano's history. Stratovolcanoes are the most dangerous type of volcano, capable of producing explosive eruptions that can send ash and debris high into the atmosphere. Yes, not just the air but into the atmosphere itself. Mount St. Helens in the United States and Mount Fuji in Japan are two of the most popular stratovolcanoes of them all. Mount St. Helens erupted in 1980, killing 57 people and causing over $1 billion in damage. Mount Fuji, on the other hand, is Japan's tallest mountain and a stunning example of a stratovolcano. This might just be the most popular volcano in history. What you might not know, though, is that Mount Fuji's last eruption was in 1707, but it remains an active volcano that could erupt again in the future. Despite its potential danger, thousands of people hike to the summit every year, drawn by its beauty and spiritual significance. But the danger still looms. You never know when Mount Fuji might erupt too, taking thousands of homes with it. But you see, that's not the limit here. Some volcanoes know no bounds. One of the worst ones caused an impact that changed the entire landscape of the Earth. It was the Volcanic Winter of 536. This was a catastrophic event that plunged the world into a prolonged period of darkness and cold. It is considered to be the most severe and protracted episode of climatic cooling in the Northern Hemisphere in the last 2,000 years. The precise source of the eruption that caused the Volcanic Winter of 536 remains a mystery to this day. While there are many theories, no definitive evidence has emerged. Some experts speculate that the eruption may have occurred in Iceland or North America, while others believe it may have happened in Indonesia or even South America. But the thing is, the origin here didn't even matter. The impact of the volcanic winter extended beyond Europe, with accounts of the unusual weather as far afield as China in the Middle East. The initial eruption ejected massive amounts of sulfate aerosols into the atmosphere, which reduced the solar radiation reaching the Earth's surface and cooled the atmosphere for several years. In March 536, Constantinople began experiencing darkened skies and cooler temperatures. But the worst was yet to come. The volcanic winter had a profound impact on the climate and the natural world. Summer temperatures in 536 fell by as much as 2.5 degrees Celsius below normal in Europe. The lingering impact of the volcanic winter of 536 was augmented in 539 to 540 when another volcanic eruption caused summer temperatures to decline another 2.7 degrees Celsius. There is evidence that there was another volcanic eruption in 547 which would have extended the cooler period. The effects of the volcanic winter were catastrophic, causing widespread famine, disease, and death. The cooling temperatures led to crop failures and food shortages which, in turn, triggered the plague of Justinian. The plague, named after the Byzantine Emperor Justinian, was one of the deadliest pandemics in human history. It is estimated to have killed between 25 and 50 million people, with some estimates suggesting that it may have wiped out up to 10% of the world's population. The combination of famine and disease created a vicious cycle of death and suffering as people weakened by hunger and malnutrition succumbed to the plague. Their bodies became breeding grounds for the fleas that transmitted the disease to healthy individuals. The impact of the volcanic winter was not limited to the Byzantine Empire. Cooling temperatures and reduced sunlight caused by the volcanic eruptions had a global impact, affecting weather patterns and agricultural productivity across the world. The late antique Little Ice Age, which was initiated by the volcanic winter of 536, lasted for several decades and caused widespread hardship and suffering. Overall, the cold disrupted growing seasons and crop yields, leading to food shortages and famine in many regions. The decline in agricultural productivity and the resulting food shortages contributed to political instability, social unrest, and the collapse of empires and kingdoms. But you might hear all of this and think that was then. There's no way something like that could happen now. Well, that might just be wishful thinking because it's happening. On the 15th of January 2022, the Hungatanga volcano in the Pacific erupted with a force equivalent to 110 megatons of TNT, twice as powerful as the biggest H-bomb ever made. This unleashed a massive amount of water vapor and aerosols into the atmosphere, triggering a phenomenon that would shock the world. Located in the Tonga Islands, the eruption began in December 2021 and reached its climax in January 2022, when the energy of the eruption shook not just the Pacific but the entire planet. Researchers from all corners of the globe arrived to study this phenomenon, and its aftermath, which is still being analyzed even a year after the event. This submarine volcano reached a volcanic explosivity index of 5.7, making it the most powerful eruption since Mount Pinatubo in the Philippines erupted in 1991 with a VEI of 6. The index is based on various parameters, such as the volume of material ejected and the height of the plume produced. It ranges from 0 for eruptions of the type found in Hawaii or the Piton de la Fournes volcano in Reunion Island, which expels highly fluid lava with no explosion, to 8 for the most extreme cataclysms, which only take place every few tens of thousands of years. So to say that this volcano is unpredictable would be a massive understatement. What made Hungatanga unique, however, was the fact that it was a submarine volcano, unlike Pinatubo which was on land. Hungatanga's magma chamber was only a few tens of meters beneath the surface, with two portions of the caldera above sea level forming the uninhabited islands of Hungatanga and Hungamai. This led to a huge amount of water reacting with the lava, which would have prematurely stopped the eruption had the volcano been located at a greater depth beneath the ocean's surface. But because it's not, things got really crazy, really fast. The explosion blasted material right through the entire stratosphere and into the mesosphere to an altitude of 58 kilometers, making it the tallest volcanic plume ever recorded. The extremely rapid disruption of the atmospheric column initially generated a whole range of acoustic and gravity waves, which were recorded both on the ground and from space. The shock waves were so powerful that they circled the globe several times. But the plume wasn't the only consequence of the eruption. About 140 megatons of water vapor were also released into the atmosphere at a speed of 40 meters per second. In the stratosphere, the quantity of aerosols increased five-fold, while the mass of water rose by 13%. One of the key concerns for scientists was the impact that the eruption could have on climate change. Eruptions release gaseous sulfur into the atmosphere, which then condenses, forming aerosols. The latter reflects solar radiation, and insufficient quantities can cool the global climate. The presence of large amounts of water, however, oxidizes the sulfur, which resultingly gives rise to larger, heavier aerosols than if the event had taken place in the open air. This speeds up their descent, especially since the short duration of the explosion, which lasted only a few minutes, meant that less sulfur was emitted than during other such phenomena with a similar VA+. The vapor is expected to remain airborne for several years. This, combined with its greenhouse effect, could alter global circulation and worsen polar ozone depletion. Now, this might be confusing because we discussed the case of the volcanic winter of 536 where a massive explosion cooled down the Earth. Major volcanic eruptions do tend to cool the planet temporarily because they release sulfur dioxide particles that reflect sunlight away from the Earth. But this eruption was different. Instead of sulfur dioxide, it was water that was being thrown into the atmosphere. So, the effect would be entirely different. Before the eruption, scientists thought there was a 50-50 chance that global temperatures would exceed 1.5 degrees Celsius above pre-industrial levels at least once by 2026. But now, thanks to the eruption, that likelihood has increased by 7 percentage points. In other words, it's now more likely than not that we'll exceed the 1.5 degrees Celsius threshold in the near future. It has been a year since the eruption of the Hungatanga volcano. Researchers have been exploring every corner of the Earth to learn more about this incredible occurrence. In recent months, scientists have made groundbreaking discoveries, including new vibrational waves that caused tsunamis in distant ocean basins. They also witnessed the highest concentration of lightning ever recorded and a significant release of water molecules that filled the upper atmosphere with enough moisture to trap heat underneath, warming the Earth for several years to come. Scientists are now trying to determine the magnitude of the eruption and how extraordinary it was. This is important because it has implications for the hundreds of underwater volcanoes that exist in the oceans, which could pose an unforeseen danger. According to Shane Cronin, a volcanologist at the University of Auckland, the Hunga eruption highlights a new type of volcano and new types of underwater threats. Right now, only a few underwater volcanoes have been extensively studied, such as the Axial Seamount and Kikum Geni, which are equipped with sensors that monitor for rumbles. However, many more underwater volcanoes are situated in remote parts of the Pacific, making it difficult to study them. There's no real infrastructure for this field yet because, up until a few months ago, no one even knew things could turn out like this. Even studying Hunga is no easy feat. For starters, the volcano is located in a remote part of the Pacific near the island nation of Tonga. Getting there requires a large, fully crewed research vessel equipped with multi-beam sonar and water sampling instruments. But taking a boat over a potentially active area is risky, not so much because the volcano might blow, but because the gas bubbles might cause a ship to sink. Despite the challenges because of this explosion, researchers are finding new ways to study submarine volcanoes. By studying submarine volcanoes like Hunga, they hope to gain a better understanding of how volcanoes work and how they shape the world around us. And who knows, maybe one day we'll be able to predict when the next underwater eruption is going to happen before it even begins. And on that note, we'll wrap up today's video. Do you think there could possibly be another volcano as powerful as Hungatanga? Let us know your thoughts in the comments below. If you liked this video, please give it a thumbs up and we'll see you in the next one.